Okay, so welcome everybody. So this is um, today we're going to have a presentation by Angie Mendez. She's a BIM manager at A-Lab, our Norwegian partner. And so we have, I'll just briefly present so that we all know more or less who we are. We have people from academia, which meets more or less me from State Laboratory of Civil Engineering, from A-Lab Portugal, from Universidade do Minho, and from Marta Campos from the Portuguese practice, and who am I forgetting? And Philippe from BIM consultant. So it's I think we have a good mix of people working in this area of sustainability and BIM. And so the idea today is to get one first look at the BIM practice in A-Lab. And so Angie is going to present whatever she has. So it's going to be, I guess, a general view of their work, and then we'll have time to ask questions and to discuss, and then we'll schedule later some more in-depth talk about more specific aspects. But like Angie just said, this is a very fluid landscape. It's especially in what's related with sustainability in construction. Well, BIM has already it's also fluid, but some things are more or less set up and prone to change, but they are working. But in sustainability and circular materials, we are in our first steps. So, okay, let's go and welcome Sebastian.
Thank you, Ricardo. Sorry to.
Yeah, no, it's great.
Come in like that.
So, Angie, go ahead. Thank you, and thank you very much for being with us today.
Thank you for having me. What I have done is try to put together all the things that we have been working on for the last couple of years. And I mean, it's up to you. I'm here for you. So you can decide if you want to take questions and comments in the end, or if you just want to interrupt me along the way, because there's a lot of topics. So as you said, I'm not going to go into the technical aspects of things, but more like the overall picture of why we're doing certain things, so you can see how it fits your goals. In principle, I use as a reference the pointers that you gave me. I didn't know what hygrothermal behavior is, so I'm not going to talk about it. I had to Google it, so that's a bit out of my scope. But otherwise, we have examples of almost everything. So let's see. We are an architectural company based in Oslo. We are about 115 people, I think. And we have a sister company in Alvor in Portugal. We have, projects in all different sizes, from charging station for solar energy to 500,000 square meters urban developments. So that makes it very interesting for us to test new technology, because then we can see what it means in different scales. And we're a project-based company, so we're all the time looking for partnerships. I myself understand now that I'm not going to learn everything there is about tech. So I try to work together with a lot of startups that are coming up in the market and try to help them connect with the clients and the projects to find these market needs. We have been using BIM since about 15 years ago. The wave happened. I mean, when I came to A-Lab, they were still working in 2D, and that's, maybe 15 years ago. So BIM started being like the first dimension of VDC, which is what we call virtual design construction. And we see that it's static data, but you can use it for different purposes. So what I call the different dimensions is you have 3D plus information, that's BIM. And then you have 4D, which is BIM plus time. And then we have 5D, which is everything to do with cost estimation. And last but not least, 6D, which is BIM for facility management. So for me, it's a very natural evolution. Often the technology needs to evolve to a certain point before you can start looking at new applications. So this is a little bit in the order where how people has implemented it in Norway. So we did map the private sector. Normally we work that, like our clients are normally the developers, and the developer would hire a contractor. But the developer has under in his own network, they have, of course, the realtors, the building owners, often they sell the buildings. They have the facility management team, and they have the tenants. So mostly, and still now, although this is changing, BIM, it has been like the way to connect the contractor and all the consultants, so the engineers, the architects, the people in manufacturing, and all the dealers. But what we see is that in addition, you have the public, the authorities, and you have the population in general. And now it's a shift trying to move this information that used to be very basic for construction and put it front center of the entire ecosystem so that everybody can benefit from these possibilities within the data. And this is possible because we are experiencing what we call the fourth revolution. So of course you have, steam, and then the second was electricity, the third one was robotics, and now we are in what we call the industry 4.0. And without getting into too nerdy stuff is, a lot of new technologies and networks that is maybe not so obvious like the others because it's a lot of parts that are baked into this. So you have mixed reality, you have the Internet of Things, which means sensors, you have big data, cloud computing, and all these technologies together are a bit of a groundbreaking experience for architects. And we see how it has increased how quickly we implement these technologies. So that's why I wanted to show you this diagram that shows, okay, when we started with the phone, it took 75 years to reach 50 million users around the world. And then it came the radio, it was faster, the TV was much faster, the iPod 4 years, the internet 3 years, Facebook 1 year. And I don't know if you see here under, let me see if I can. Do you guys see the cameras in your screen as well? Doesn't matter, but okay. The last implementation was this Pokemon Go, which is this AR game that was that reached 50 million in 19 days. So what we see is that these technologies allow us to have this kind of like circular building mentality. When you start with the concept and with the origin of the project, and you build up all this BIM data that is used through the construction process, and then you layer, and this is called real-time data that is coming from the sensors that are installed everywhere now, which is used for facility management. And during the evolution of the building, you need to use this information for understanding how the building is really performing and potentially optimizing. And when you reach the point where the building has done its part, then you can, of course, start the process again. So, and this is the whole goal is sustainability. But of course, in theory and in a diagram, it sounds all very neat and very obvious, but we had to test it. So this is our office in Oslo. This is where I am in this small box here. And what we had to do was to try to layer up this information before we could offer it to our clients, as a service or a way to support them. So we start with the BIM data in the bottom, and then we added a set of sensors. And then we started looking into how you analyze the data to convert it into services. And from there, you have on top, then again, the optimized architecture or urbanism. So what we did was to, first of all, create a model, a BIM model from the building where I'm sitting. And put inside like just the most basic information that we needed about the functionality of the rooms and so on. And then we connected these proximity sensors. We're collaborating with a Norwegian startup called Disruptive Technologies. They have these little sensors that I have placed on the chairs that when you sit on it, it recognizes that you're there. So whatever that is green, anything that is green, it's available. If it's red, it means that a person is there. So it allows you to see how we're using the office in real time. Especially became important now with Corona that we cannot use the office to full capacity. So it was a really good indicator of when we could come in or not. So based on this occupancy of the rooms, for example, we took these 3 meeting rooms that are here on the line to see to which extent do we actually use them. So we discovered that the 2 bigger ones were in use around 60%, which is sadly what most office buildings are used for. But we saw that this small one here where I'm sitting now was used on average 18% of the time. So then you can start asking yourself why. So we look into the data from the sensors here because we have different sensors. So the diagram on top is showing the temperature. So you can see that often it goes above what is sort of recommended for office buildings, right? You have to do studies in all these different fronts because then what is the perfect condition for an office building to increase productivity? And then we look into some numbers. Those are the numbers here. So we know that temperature between 20 and 24 is ideal for productivity. So we saw we had a lot of peaks above what it's recommended. And then we tested the air quality. So those sensors, you don't see it from this camera, but the air quality is also impacts. So I'm sitting here and it's very warm. The air is not great. So nobody uses this room. And so these kind of insights that you can generate combining the BIM data with the Internet of Things, it started becoming a little bit interesting. And then of course we have a lot of efforts with other companies where we try to test the ideas in social VR. So we can look at different possibilities and different layouts of the office, and then we can discuss it together. And it's very easy. I mean, you have everybody's talking in your ear. It feels almost like if you're there. So it's a way to make the BIM data available for everybody. It's almost like a democratic way of using BIM. And I mentioned that I thought that it was important to use GIS data, which means I'd say geographic information, geolocalized, based on the positioning, right? And I think this is important. This is an example of another study we did more like in a city level. So here you can see the buildings everything is in BIM, and then we put it inside which kind of buildings it is, so you can visualize that, but you can also see in which year they were built. So you can start creating this animation that shows how the city grew, and then you can add more and more layers. So in this case, for us, it's important on where there is nature, where there is potential, how clean how polluted the air is, like the municipality of Oslo measures all those things. And last but not least, we have traffic information that we can overlay on top of the BIM model. So you can actually see here to the left, you can browse through the different hours through the day and see how the traffic actually behaves. So this allows you to plan differently or take into consideration this kind of open source data. So that's why I thought that the GIS data could be important, especially when we're talking about reuse, because if you want to start moving materials from A to B, you might need to know what kind of transportation you need, where exactly do you find them, and so on and so on. So these are just examples of things that we have tested. Again, we collaborate with different software companies to get to this point. So we see that, okay, there's a lot of big data that has been generated. I mean, what is it? Is 95% of all the existing data has been generated within the last 2 years. So we are still trying to make some sense out of it, and it's increasing as we speak. So what we feel that we need to do is to be able to visualize it and then potentially create insights and translate that into actual architectural solutions. So the reason why we do this is because we see that in a typical project, right, you have a team, and then how long it takes for you to learn and to get to the maximum potential of the building, how much you optimize, is something that through the experience of the project, we all develop together. But we see that, yeah, for the next project, when you start at this point, you start a little bit higher because everybody learned a little bit. And so that's this in the second goal, then you are a little bit smarter and you optimize more. But we think that what if we will continue learning from the building once we have delivered the keys? And that will allow us to have this exponential kind of learning from everything we do. So the next project, we're in a much higher level. And we see that the challenges that we're starting to face are so complex that all these traditional methods have reached their limits. So we have to start thinking in this kind of exponential learning mentality. So Open BIM is the origin of everything. This you see in gray is the traditional way of working, right? Where you come in the early design process. We start as architects. It's a lot silo kind of mentality. So the architects start working alone here, a big part. The construction starts and then they bring in all the other consultants. And there is a lot of, if this is the design effort and this is how long it takes us, then we see that we use a lot more money making changes than on the BIM sort of workflow where you start very early. Everybody is actually finding the maximum potential in the project. So we invest more in the beginning, we make the best project possible, and then we just document it. So that's sort of like what BIM is trying to accomplish, to sort of switch where the effort is made, because we know that is more effective and that is cheaper. And instead of the engineers coming in and just trying to solve whatever we come up with, they actually work together with us to help us find the best solutions possible for the best project. So the BIM workflow that is in place, it's sort of like, okay, the traditional mentality is very linear, right? All the consultants came after another. But what we do now in this sort of Open BIM mentality is that you have all your milestones, and in between those milestones, there is always this goal review. So it's a constant iteration process where you test the design, you test that all the components are working, and I'm thinking all the disciplines are part of this, you know. So you have this key role of the BIM coordinator. I remember it was new when I moved to Norway, and now every company has their own people, where you see when you compare the tasks and the results, and then you use this this kind of review to make all the best decisions for the project, so it doesn't get off the tracks without anybody noticing. And so there's a bunch of methodologies that we use within this process. And who runs this process, it depends. Sometimes we do it as architects when our clients don't have the in-house experience. We can do that. It's a well-paid job. I like it. But now most of them have their own BIM departments. So we are just one more participant in the process, and more. So how do you actually get there? I took a print screen of the BIM execution plan that we attach to all our contracts. So before we start a project, I always demand that they will, that they will clarify, and I translated it to the best of my ability. But let's see, you have the contractor, the consultants, and the developer. And it's all about understanding from the start what is BIM going to be used for, so you don't draw too much or too little, right? So if you understand how success looks like, it's very easy to see where you are in the process. So this is something that we contractually required to specify in the beginning of the project to see how that affects the finances of our services. So common BIM uses, we can go through it very quickly. Visualization and orientation, this is especially useful on the site. There is most construction companies now have this thing they call a BIM kiosk. It's nothing. It's really like a table on wheels with a computer that they have on the side and with a computer with Solibri, and everybody can go to the model and look at it and use it to understand the drawings because it's just like an aid. And of course, for the clients and the realtor and all these people that is maybe not so used to reading drawings, is a big help just for orientation. We use it for visualization and animation, mixed reality, all those things. Daylight calculation, which is probably not a problem for you guys down there, but for us it's a huge issue here. So noise calculation combined with light and wind conditions is something that we have started working with in a more systematic way. Fire simulation, structural analysis, energy use, performance, gas emissions. Survey data for the site, of course. Machine control based on BIM. This is what we call 4D. I'll show you an example later on. And how you can actually do your scheduling based on the BIM model. And it allows you to see how off you are from the plan that you originally set for yourself. So this is very good also for the 5D, which is quantity takeoff and pricing. So because it's dynamic and the design is changing all the time, but with these tools, the building owner and the contractor are able to see how on point they are according to their own planning. Or anyways, like they're able to adjust a little bit faster. And they use this on the site to, order all the machinery. I remember in the Statoil project, one of our iconic buildings, we had hired a crane that cost 100,000 crowns per day. So it was very important that we wouldn't have it sitting there when the rest of the work was not ready to start. So for those kind of things, it could make a difference if you actually use the BIM data that is updated for this kind of planning. So yeah, crash control is a no-brainer, right? One pipes crossing ceilings and that kind of thing. BREM and area and room calculation. This is very important for the client. So they can, when they talk to their investors, they can show that the program is actually answered to the economical needs of the project. And then, of course, facility management, that is all this stuff with digital twins, and mixed reality, which is a lot of fun. So you ask about I think you call it procurement. I understand requirements, so correct me if I'm completely off. But in Norway, we have Statsbygg, and they are the building commissioner, property management manager, and developer. They build everything that is public. So all the hospitals, all the airports, all the schools, all the universities, everything that on that kind of scale, they are the client. So naturally, they are one step ahead of the rest of the market. So whatever they decide as requirements sort of pushes the whole industry forward because we all want to work with them. It's the biggest client there is. And so they actually are a big influence on how things have developed. And I was a bit worse here translating, but I'll try to take it on the go. They have done a lot of studies and invested a lot of money on understanding what digitalization means for the industry. So according to their own statistics, they think that they can reduce costs by using a fully integrated BIM environment by 33%. They can reduce the carbon footprint of the building by 50%. And they can reduce the time of execution of the project by 50%. So it sounds like a no-brainer when you put it like that, right? But then they discovered that they have been also measuring all the deliveries that they get, because when you deliver for Statsbygg is full BIM, the highest requirements there is. or used to be. So they measure from all the models that they got since 2011, how many deliver a BIM model. And that was, you see, like, yes, 50%. In how many projects all the models were delivered to the level they require, and then is much less. And then in which projects it was 100% correct, and then it was virtually nothing. So they started thinking, we're doing something wrong. And the BIM manual for Studsvik, I downloaded it for you in English. There's an English version. It used to be a PDF with a lot of really hardcore requirements. So of course, especially for smaller offices, it was really hard to follow, you know. I tried to use this diagram to explain you quickly what it means. It's you know, I'll send you a link, because there are quite a few pages of requirements. However, the main point is, okay, they have a requirement database. You have the design tools, and they have, everything is based on open standards, right? So they are expecting from the design team to get IFC format, which stands for Industry Foundation Classes, which is simply the neutral language of BIM models that any software can read, right? And then, as a communication standard, they use BIM BCF, which is BIM collaboration format, which means that all the issues that are created in the project, you are able to track them back to the objects they belong to. So it's very good, because when you do, for example, a crash control and you find two objects that are problematic, you can put this BCF report back into your drawing tool, and the program will take you exactly to where in the project the problem is. So it's just the BIM version of communication, right? It just recognizes the unique identity of each object. And then they have, I had to explain this a little bit because I don't remember from the top of my head. MVD means model view definitions. So it's really rule sets that they have created themselves, which are requirements for the projects. So say, for example, I did with them a university. You remember, Luis, that university project? And we lost that competition, damn it. But,
the one we lost, right? I don't remember that, no.
Never happened. So, but what we did was that they had a program with the amount of square meters that was required for every specific room. And it was a rule set that we had to run the model through to make sure that we were fulfilling the program. Because it was a competition and they don't have a person that is sitting there and measuring all the areas and making sure that that's correct. Those are all digital rule sets. So what they have created is this thing called MVD XML, and that stands just for the machine validation version of those rules. So now you can actually use this in any software, and you yourself, before you send it to them, know if the BIM delivery is okay or not. So I'm going to show you, because I know that this thing sounds super heavy. I have a video now that I will show you how I do it, like in the program. These rule sets, maybe that's interesting for you, are all based on either international standards or Norwegian standards. So that's good, because then everybody understands where these rules are coming from. And then it's divided mostly in three big chapters. You have the model praxis, and that means the quality of the model. And here is where I will send you a link later. It's based on every type of object, and then it's about how it should look in every phase of the project. So this is very specific, and again, whatever you're interested on, we can go much deeper into it. Hopefully not this one is the boring part, but you can also read it. Then you have the coding system, which is based in a Norwegian standard, but it's pretty close to the uniform classification that you're already using. So it's just to sort of categorize all the objects within BIM. And then you have the process status code. And this is the thing that I was telling you, that it was developed by these friends of mine. It's called MME, and it stands for Index of How Mature the Object Is. So I'll show you later how we use it. But anyhow, these rule sets this is just a program. So this is called, all right, so I see that there's some noise here. Let me see. Because if we both talk, that's going to be a little bit problematic. Let's see. All right. So we use this program called Simple BIM, which is for IFC management. You also ask in your list of topics, how do you actually administrate all these parameters? So that would be Simple BIM. This is not, I cannot draw here. I can only open IFC files and look at them. So in here, you see that you have that format called embed XML. So I can actually just load the rule sets, in this case from StatsBig, but it could be anywhere, right? So as long as the rule set is digital and in this format, I can simply load it and ask to be tested in this particular project, right? So the StatsBig actually provides you with all the templates for all the rules, and then you choose in which phase of the design you are to check the correct one. And then it will automatically find all the weaknesses in your design, all the things that you need to fix before it comes to them. And so it's really user-friendly. And it will highlight all the elements that are not complying with the requirements. So you can send it back to the design team, tell them what to fix. You check it once more, and probably we're going to achieve, I don't know, 95% of accuracy. It's not that military. But the important thing is that you can also choose to what part of the geometry you want to use. These kind of tools are very useful because, like you have the typical architect thinking about other things. I mean, this kind of like depth of technical skills is not something that you can expect from every single architect in the world. So it's important that you have these roles and these tools that support the process and supports the people. And of course, you try to make it as automatic as possible. So the thing is that here, once you apply this template, you can see here on the left that it's making a report of all the objects that are not compliant. Something is missing. It could be information. It could be that it's in the wrong level. It could be anything. But then it allows you to very easily, for example, you have 52 doors that have problems, and then you can highlight it, isolate it, look into it, and you can even correct it from here directly. If it's not a geometry problem, because you cannot draw here, but if something is sitting in the wrong level, you can change it directly in Simple BIM. So that's a way for us to be able to administrate all those parameters as a post-editing kind of process. So so these people is quite ahead. This team, they always hire the best people in town, and they have pretty fat budgets. So it's important to keep an eye on what they're doing. And I see, again, this is in the region. Let me see. This is their plans for the environmental applications of BIM. So there is all these topics. There's material and energy use. There's garbage management, ecology and landscape, water use, climate adjusting, transportation, and health in the working space. I don't know how you call it. So these are the main sustainability topics in the government at the moment, and they have chosen material and energy use as their area of focus, because this is all so big. I mean, we're going to retire and not get any closer to solving all these problems. So they had to pick something. So they chose materials and energy use. And what they're doing right now is mapping the premises based on every discipline of what could potentially look like a requirement set. And what they think that is going to happen is that in 2021, they're actually going to give the first set of rules for this environmental use. So again, you see, like I told you in the first meeting, Ricardo, that you were a few years behind when it comes to certain things in BIM. But in this sense, this study and that we're sitting here together is actually helping you catch up, man, because as you can see here, we're all pushing for the same goals, you know? So this is an opportunity. Another very interesting, so that's, you know, that's from the private sector, right? Finance with oil money. Now, for the private initiatives, this is a really interesting project. It's called Future Build. And it's a vision on how to create climate neutral buildings, right? And the whole point, it started with 50 pilot projects that would supposed to generate the least amount of greenhouse emissions possible. So the real target became 50% of the goods. So it's a little bit different if it's an existing building, because then you have to take into consideration that at least 50% of it you have to keep, otherwise it's probably not rehabilitation anymore. And then you should have at least 10% of reused and 10% recycled materials. If it's a new building, it has to be a total of 50% of the building, 20% reuse, 20% repurpose. And this is a bit weird because it doesn't add to 50, but we get to complain to Future Build about this bad diagram.
No, but those are minimums.
Yeah, yeah.
So you have to add up to 50, but you know, this is the minimum of each.
So it's a very interesting effort because these 50 projects of Future Build are becoming like a landmark, a reference for a lot of clients and our architects to know what you can achieve. Maybe if it had been, you know, maybe just 15%, it wouldn't have had the impact to become a benchmark. So we heard just this week from one of our clients that they were having the 50% requirement. And it's like, sure.
But Angie, can you explain a little bit better? You applied to be a Future Build project, right?
Yes. So these 50 projects, it had a specific initiative. So the first 50 pilots were chosen. So those buildings were designed with the specific purpose of achieving 50% reuse. But since then, more projects have popped up that use that as a reference. So now you can apply to be part of Future Build. So it's kind of cool. I think we have maybe now the first project we can apply for. But it at this point, because it's so early on this, it gives you a little bit of status, you know. It's a bit prestige that you are up there with the 50 most environmental projects.
Is there other benefits or just recognition?
We are transitioning now from being a competitive advantage to being a requirement. So I think that we already have crossed the line where it gives you, where it's a PR thing, towards like, we really need to get there. Because again, like Norway, since it's such a small country, things happen very quickly. So once everybody agrees on this 50%, you have to comply. So I feel that it's going already away from a competitive advantage into more the way how we're expected to work. Very quickly, man. But it's a good thing. So when it comes to this kind of private projects being requirements, I wanted to show you this project because this is Schienbrygge. This is, you see, it's a quite nice urban development by the water, and, you know, like an hour outside Oslo, maybe less, maybe 40 minutes. And this is the first project that has been fully designed for becoming a digital twin in the facility management phase. So we know from the start, and this is interesting. Again, guys, I didn't translate everything, but I'll show you. This, in the first column, you have all the different building components. So this is what you will have here, the Unicode. So columns, fundaments, walls, and so on. So you list all the building elements. And then in the next tab, you have the information that is in the model. So this is, for example, when you model it, in which level of detail, what is the U value of the glass, what is the sound and fire requirements, what is the product information, and here comes the MME. I'll tell you what the MME is in a second. So this is information that has to be inside the model. And then for facility management, they have their own set of information that is not in the model, but is connected to the model. So then you have operations kind of information, what kind of maintenance routines you have for that. What is the product information that is interesting at some point where you have to change it, you know? How do you use it? Pictures, references, you know, guidelines of how you repair stuff. So this is information that needs to be connected to the correct building objects in the BIM. So when I discussed this for the first time with the COO in Alan, he freaked out because it always comes down to who is going to do this. You know, this is so outside of the standard architectural contract. So we sat down together in the team and tried to see how much of it we can make automatic with scripting or with tools that the providers already have. And then it was not so much left. So we think that what corresponds is that the contractor that knows all the product information will manage to bring that back into BIM. And it doesn't need to be this super complicated, you know, like programming, ultra nerd stuff. It's very easy to use Excel as a way as a bridge between BIM and other disciplines. So as long as you use the correct formats, you can always send information out of the model and bring it back after somebody else has filled up their part of the information. So you see, it requires also that you're a little bit open for the discussion, at least. But when the client comes to us and said, okay, we have digital twin requirements, that really shows that the industry is coming one step further. You know what I was telling you in the beginning, that the BIM used to be a side thing, and now it's coming front center from all the ecosystem. So this MME parameter that was, you know, just for you to remember, is one of the, I don't know if you see my pointer, but this MME is one of the parameters that is included as project information, right? So this is a parameter for status. And this is the story I was telling you. A bunch of guys here in Oslo, we all started together back in the day, so we know each other. And you just sit down and see what can we do to work together to improve things. And we recognized very early on that to be able to know how further ahead every discipline is on the design was a big plus. So this MME concept developed from the English standard of the level of detail. But the level of detail normally answers only to the geometry, how much geometry is supposed to be detailed in 3D at this point of the project. But we wanted to have that. And so you see, I don't know if you're familiar with the level of detail, but they go from 100 to 500, where 100 is just a placeholder and 500 is as built, right? And then you have different developments in between. So it's the geometry, but it's also connected with the status. So for example, when you're sketching is 100. When the concept is ready for internal control, then we move to 200. When it's ready for interdisciplinary control, then we move to 300. And when you already have control it, that means that you cannot continue moving stuff because everybody else agreed that it was correct. So then we have 350. And then finally, for drawing production, and those are all the production that goes to the site, you have to have 400. And then, of course, it's built 500. So you see, it's sort of like something that developed locally from an international standard. So that's why I thought maybe it was interesting for you to see, because now all the clients just embrace this. And now it's a requirement. So suddenly it becomes really fast industry standard.
Angie, just can you get back? So this MME is a level of information that you should have in the model, or is an indicator of the status of the model?
It's both, because most importantly is the status. But it's also correlated with how much information you need to know about that object in order to be able to do that control in a meaningful way. Because if I place an object as a placeholder that doesn't have, like, let's say a window we have without the shading, then we cannot really control it interdisciplinary until you reach that maturity. That's what we call it, the maturity index. Because it's only when the object itself have reached that maturity that it makes sense to control it interdisciplinary. If not, you will create a lot of double work. So that's sort of like we're trying to find this lean system. And so we color code this in the models. So you can right away like just open a view and see in which different status things are. So I would say if I would have to prioritize it, like first the status and then the amount of geometry that sort of equals to the level of detail. But it is kind of like a bit of a Frankenstein we made out of something that was very sort of like understood internationally with the level of detail. So we just gave it our own spin to make it a bit more meaningful.
Okay.
So the requirements for this project, this is how they look. They even show us exactly how they expect it to look. So you have the BIM model where you show the object. At the point of delivery, you are probably around 400, 500 if they actually decide to control on the site that things are correct. So this is as detailed as it gets. And then you will have a picture of the actual object, the page with the instructions on how to put it together and apart, and plus all the information about the maintenance of that one particular object. And so hopefully this BIM data is going to follow this project through the entire circle that I showed you at the beginning, because actually now it's supporting information that is relevant in the next phase, not only for construction. So we'll see.
So I have a question in the other slides.
Yeah.
This PDF at the center and the photo, they are not in the BIM model. They are in a database that is linked to the BIM model.
Exactly.
Okay.
Exactly. Because for example, if it could be a link to the internet, you don't have to store the PDF yourself because then suddenly you have like 1 million. So it could simply be an internet address that you connect to the object, and it's like maintenance parameter, and then it will take you there. Because also like that secures that your product information will be updated. So if something changes, you also get the latest, and you don't need to create this sort of storage solution that will make everything more expensive. But these kind of pictures, it's normally the building owner themselves. They track things, and if something changes, these maintenance guys take a new picture, and then somebody is in charge of replacing it. We're trying to figure this out. It's not everybody that is so like tech savvy. So they really need to understand their own way of working. And in Norway, there are two models. You have the people that buys buildings or builds, and they will do all the maintenance themselves. And I mean operations, not maintenance, because operations includes making sure that the lease is always up and running, and all the administration and the maintenance and all this work. Also, everything related with operations. So they either subcontract it or they do it themselves. And depending which kind of client, these things look very different, So I think if in a few years, it's going to be quite standard as well, Just the idea of having one centralized database where everything is always correct, because the problem with this, with the situation as it is now, is that everything is in silos. So if you ask different people, you will get different answers, and it's one building. So BIM becomes like the backbone of this database that you can use to connect everything, because in the end, it's simply a representation of reality, right? Yeah. So when it comes to sustainability, I wanted to show you sort of like how we're thinking in A-Lab. We have an in-house group that we're trying to lift the level of understanding of where we're going with this. How are we going to market it? What kind of services this is going to create. So we have this template for the project kickoff. So what are the things that we need to think about when it comes to project and sustainability? Because I think obviously with this research, you have to narrow it down and focus in one topic, or otherwise it's way too broad. But this is just like in general, the steps that we describe. So we start with climate and ecology. Then you have number 2 is social sustainability. Then we have energy use and the optimizing of the volumes and, like the main principles of the concept solutions. Then you have landscape and ecology again, what happens with the water and the green and all this stuff. Facade design, very important for daylight. Then we have system integrations for everything that is with ventilation and so on and so on. And finally, we get to the optimize of material and energy. So that's sort of like the last step of our program. So I'm just going to focus on this for a little bit. The other topics, we are prioritizing them in different levels also. So some of them we are a little bit further ahead than others, but we can always discuss whatever you're interested in. But I wanted to show you this because if we focus on the materials and see where we are when it comes to reuse and recycle in Norway, we see that Norway is a very wealthy country, so our economy is quite large. And out of the whole economy, according to this circularity report that came out recently, we are only circular in 2.4% of the totality of the economy. So that is way too little, right? There is 97% room for improvement. That's just crazy. So we see that that's a general an approach that many people want to solve from the top down, from the politicians down to the citizens themselves. There's focus on circularity. Now with Christmas, you have all these blogs and articles about how to use presents without hurting your loved ones. It's kind of like a trend. So what we see is that in order for this in the building industry to be effective, we need to involve everybody in the ecosystem, in the process. So it's not only the design, but it's the builder has to be able to do it, and we need to be able to implement it and think one step further. What happens when we're actually going to put it apart? So you almost need like a crystal ball on what is going to happen 60 years from now when the building has completed its cycle. And for that, in the design phase, you have the architects, but on the building part, you need to have the client needs to want to do this. And the construction companies need to keep up with a new set of detailing and use of materials that they are not really used to. And, the private owners and the government, of course, need to have a strategy in place. And then the demolition companies are going to disappear because then there are going to be reuse companies instead. And then we need to create these marketplaces where this exchange of materials can happen. That's something that I mentioned quickly in the first meeting we had, but I have this friend that started a company a few years ago and is growing and growing, where he creates a database of materials that are available for a client from building to building. So if you want to reuse something, it's a bit basic now, but let's say you're looking for a chair. So you can go inside the database of your organization and see if something is available that you can reuse. So these kind of marketplaces are going to be key moving further on this possibility of circularity. So I wanted to share, because this is a private initiative, it's a big project we have here, just like 10 minutes away from where I'm sitting. It's called Lilleaker Bien, and this is, I think it's 300,000 square meters or something of development. So as you see, the picture on the left shows the buildings that are already there, and the picture on the right shows the new project. So it's going to be massive, it's almost like a city inside the city. And this client in particular has a very personal commitment to sustainability. So what they have done is to do a study on, from those existing buildings that you saw, how can we actually map it and reuse as much as possible. So they have a special, specialized company doing this for them. So the first thing they did was to calculate how much it's worth, because then again, when you talk to developers, there's a lot of focus in the money, and money is a very good argument to convince people to change their ways. So they actually saw, based on, this is the tiles, the wood, the steel construction, all the different things, that you could potentially reuse from the project and how much they are worth. So in total, it becomes this large number. I'm not going to try to read. It's in Norwegian kroner, so it's not euros, but still a lot of money. So they understood that it was worth to look at it. And it starts here, right? You have to see where the materials are at the moment. So we have to map them. And this is the process where we are at this point. But once you map everything you have to sort them in a smart way. You have to say what is in good condition, what is in more or less condition, things that need to be recycled. So within these two categories, you can actually reuse them because they are good enough to be put to use again. The ones in yellow probably need to be recycled or refurbished somehow. And the red ones is just garbage. There's no way to save that. So it was important to do it. There was a lot of buildings there, but they have actually done their job on sorting those things up. And now they are working together with us at this point where we know what we have to actually see how we can bring this back into giving new life to those materials. How can we actually upcycle all this stuff and use it in the design that we are proposing? So it's actually a lot of fun, it's new things for us. And it looks like this. So they take, you see, this is the whole project, this little map here, and then it shows building by building what is there. And this is actually in English, so this is good. So it tells you a little bit about the building, the year where it was built, and they have these comments that tell you a little bit more about what kind of material it is, but they have done this systematically. And of course, with the properties and some pictures that show, especially for us, what can we count on, how it looks. And the interesting part here is that, for example, for steel and concrete and these things, you have to test the materials on the lab because we still have to build according to the building standards, so you cannot reuse material that doesn't fulfill certain characteristics. So a lot of these materials, they just send a little sample to the lab and then it comes back with the properties that it actually has. The resistance or like how much resistance it has lost or whatever it has happened to it through its life cycle. So we have to put that as part of the mapping. And then of course-
Sorry, Angie, that was my question was going to be if there would be a challenge about certifying these products, because when you use them from the beginning, a lot of products, they have certifications, but then when you reuse, to fulfill the requirements, when they test, do they give a new certification to these products?
Yes. So the lab test counts. But not all the products need that, So they did it, and I don't think it was that expensive, especially when you compare with the potential gains that they have in there. But yeah, things like, maybe tiles and carpets and more like lightweight materials, they are not so important, but the structural components, they all need to be tested. And I guess, I can dig a little bit deeper into this, but it has to be a list of labs that are allowed to give you these results that are certified by the government again.
Can I ask something, Angie? Marta speaking.
Hey.
Do you model the existing assets and you gather the information that you attain in site in the model?
Marta, you are one step ahead.
Okay, sorry.
Because the next slide is how do you build a database? And that's interesting because in this project as well, this is pictures and PDFs, yeah? You can see here that this is pretty lame drawings from 1880. This has to be a typo. this building here has to be from 1980. Okay, I don't know. But the point is that they just had like paper drawings, studio drawings, and they complemented it with these pictures and this additional information. But we are already working in the first phase of this project. So we started using our methodology, that this is a topic on its own, but how do you build a BIM database of an existing building? So I wanted to show you quickly because it's a good question. So we start with a laser scanning. And from this laser scanning, I mean, we use different methods. It could be a laser or it could be from drone pictures. That is actually very cheap to build up a 3D from pictures. But in the more professional sense, you will create a point cloud that represents the building in the 500 level. You know, it's as close to reality as it gets. And from there, you can generate the BIM model. And then you can map the information and connect to the objects all these certifications that have been applied, right? And you can do it by type. I mean, you send a sample, it's almost like an audit. And then you know that you have applied this material in all the floors, so you can assign it connected to that type in general. So you have to make a lot of strategic decisions in the beginning to make sure that you push the model to the level it needs to be. So reality capture, there's a typo there also. The point cloud is in 500 level of detail. And then the BIM model will probably go down in level of detail to 200 or 300 max. You don't want this to become, it's not a construction model, you know, you probably can get away with 200.
Angie, sorry.
Yeah.
There is no kind of automation on this last step going from the point cloud to
There is. We're actually collaborating with this company from the US. They have created a program that does exactly that. I mean, it's not 100% automated,
but it's better than modeling the whole thing yourself.
It does a good chunk of the work for you. So we're testing it right now in a big project we have called Marine List. And so it's an urban development and it's a huge basement that is going to stay. It's this TV station. So yes, we have calculated that it will push down the time of modeling down to maybe 60%. So that is, you know, it's pretty good.
It's like,
because
like walls and floors and surfaces, like simpler surfaces, I imagine, I can imagine.
Mm-hmm. Again, if you want a demo of that, we can look into that. But I just wanted to show you how a point cloud looks like. So this is in our project in the center. So this building was going to be kept. And you can see in the point cloud that if there's somebody walking their dog around the building that particular day, you will actually get that information. So these point clouds are very smart. For example, here we're color coding the different heights. So there's a bunch of ways to visualize the information without even building anything around it. So it's often like a combination of tools that will get you where you want. But you see, you are able to actually cut through a point cloud and get a lot of information from it without having to add any BIM stuff at all. And so what we do is we overlap them. So you have the BIM model overlap with the point cloud, and then you get what you need from different sources. So that was the point cloud, and that's how the model looks like. So there is a methodology in place for how do you build this depending on what you're going to use it for. So, I mean, again, if you want, we can look a lot more into it. And am I running out of time? Almost. Jesus, I really want to hear your comments. Okay, so I look into this certification of the products. There is one system. We have been talking about it without really going so deep into it, but it's the cradle-to-cradle certification. So this is a kind of like an American approach to the life cycle of the materials. So this is more about manufacturing, right? From raw product to something that we can use in construction. And this cradle-to-cradle certification has a lot of focus on the biological side of things, the impact on the chemistry and the biology of the nature around it. So it's something that is interesting, and we're looking into it because you see, it's a lot connected with how do you use water and how do you use renewable energy to actually produce your materials. So it's really inspirational. It's really nice to use. And I know that Bream Holland is using, it gives you extra points if you use a cradle to cradle certification. So we're not using it in Norway, but then again, I'm thinking this is probably coming sooner than later. What we use is Salting EPD. I'll show you. I thought it was interesting to see because the timeline for the regulations in the Nordic countries, so it's basically, you know, Denmark, Finland, Iceland, Norway, and Sweden. We're living our little own bubble. So it was interesting to compare some of them. So we are looking at how can you regulate the expectations of how people is going to approach the life cycle assessment of the building. So if you see, like we're here in 2020, the database in Finland is already in place. So this is, we have borrowed it from Finland. They already have requirements, so laws that require how the life cycle assessment should be. In Iceland, they are getting there. In Norway, we are still on the exploration phase. It's not a regulation. And Sweden is a little bit ahead. But in 2022, this is going to become a must. So the thing is that we cannot take it at our own pace. We have a very specific goal to prepare towards. So, you know, first they give a little bit slack to the industry so everybody can catch up. But at some point, suddenly it hits you in the face if you haven't been preparing for it and positioning yourself for it. So we know that in a couple of years, everybody has to deliver in a certain level. And these life cycle stages are very important. This is also an international standard. But what we look at when it comes to and we use one program called One Click. They are based in Finland. But this database and program was developed with a lot of money from Statsbygg. So that's sort of something that they expect us to use. And the stages are, so what it includes when you think about the material life cycle as the manufacturing of it, it's the raw material supply, so where it comes from. And here Norway is very weak. I really want to show you this diagram. Then how do you transport it? And then the manufacturing resources that you use. But then the idea is that we can push this further to understand what happens to that material when you actually transport it to the construction site. So the location of the project, and if it's an import product, is very important. And how much resources go into installing it. And in the use phase, again, you see like everything relates back to this circular diagram that we looked at in the beginning. What happens to the building once it's in use? You maintain it, you repair it, replace it, all the operational use, how much energy the building uses on a regular basis, how much water the building uses on a regular basis. And of course, the end of the life of the building, how you deconstruct it, transport it, how much waste do you generate, and how do you reuse it? So those are the different stages of the life cycle assessment. And there's discussions of what's beyond that, how we can learn from that and so on, but that is not part of the assessment at the moment. And so when you hire somebody to do a life cycle assessment for you, you have to tell them in which stage you mean. And the base for that is what we call the environmental product declaration. And this is an independently verified and registered certification that is transparent and, you know, everything is available. And it shows the environmental impact of the product. So this is an example of a window, you know. And okay, we can also look at it. This is a several pages document that shows how this window from start until it reaches the construction, what kind of impact it has in the environment. So we measure this in carbon, is the carbon footprint, right? And again, we can look a little bit more into it, but there are many gases that you can emit that are toxic, but you translate all those measurements into carbon because then you have only one metric, right? So let's just call it the embodied carbon. And I wanted to show you that it's based in BIM. So this is something that we're already doing, and I'm trying to get much better at it. But you see, this is just like a normal Revit model where you can see all the categories, and then you can also look at the materials that are assigned with these categories. And if this is a work in progress design, the idea is that this is very dynamic, and then you can test it all the time. Because here, with these different colors, it gives you the percentage of impact that those objects have in the totality of the impact of the building. So if you see that you're having a very problematic area, then you can, you know, within the design process, look at it and try to optimize it, even before it goes any further. And was that it? Oh, I thought I'd show you more of how this works, because what you do next is that you will upload these, you will connect all these categories within the BIM with an EPD that shows the carbon footprint of that specific material, and then the program will calculate everything else for you in the cloud, of course. So we have discovered, with a little bit of experience that we have so far, that using materials that have a recycled content has a huge impact. So for example, concrete, that is one of the worst materials you can use. If it has no recycled cement in it, it will reach 500 kilograms per blah, blah. And if it's 30% recycled material, it's much less. This one is with a different kind of categorization, so it's the same thing. But if you use more percentage of recycle, it will have a huge impact. So those are the kind of things that we're trying to learn, and you know, some rules of thumb that we can reuse, and they become recommendations for our clients, especially when you think back that if we have to reach this 50% of reuse, what has the most impact? Because if you start with like I'm going to reuse all the wall treatments, that is 0.01%. I mean, is the construction, is the main things. So doing it in BIM gives you very quickly a scope on where do you need to focus to achieve that.
Yeah.
So
just one question,
yeah,
Angie, just back. You have to insert the information from the EPD into the BIM model like manually. Just go through the PDF and put it in the objects.
No, because the program does that for me. So
okay.
I have been thinking about this because, yeah, how are we going to do it if you don't have the program? The thing is that this program is a live database of all the EPDs, okay. Yeah, they're available in Norway, right? So I just go here into this little magnifier and click on it, and it will give me only products that are connected with doors. So all that sorting happens within the plugin, because if not, it would be, imagine, like hundreds and hundreds of things that you have to browse through. So it will automatically connect the EPD database with the categories that are relevant, and then your options are, you know, very manageable.
But you can only do that once you get to the part of the to the advancement of the project, when you know which product you will use, so yes, that you can connect to the EPD. In the first phase where you just have like a window, or you cannot do this yet.
Well, yes, because they have different modules, right? And there's a first module that works with volumes. So you don't even need to know anything more about the project than how many floors it has, and some basic about areas and the energy that it will use. And then you can get calculations that are kind of rough, but they are really good indicators where you are doing the concept, decisions. And then you have the next step, which is where you don't know exactly which concrete you are going to use, but you can say, all my structure is going to be steel and concrete. And then you duplicate the same building, you just say, okay, and what if? And then you say the exact same architecture, but if I instead use wood, and then you compare. So you don't need to go to that deep level of choosing the product. You can also choose, they have like packages where they say, okay, this is a typical facade cladding. So you will not go to the insulation, the brick, the framing. No, it will give you a package that you can choose really fast. And then it will give you these sort of approximations, right? And once you have made your decisions, then you can go one step further with the specific provider of that specific product. And then you can get a certification from there.
Okay.
Yeah. And then you will get these kind of diagrams from it. So it will tell you what is the level, right? They call it cradle to grave. So the first one was cradle to cradle. So from when the product is born until the construction. And this one is already cradle to grave. So we normally calculate these 60 years from now. Kind of like that's, I think some people that's 100 years, but we do 60 years. And it tells you in which category it is. And then it will tell you what part of the, which part of the construction is going to give you the most footprint. So you can see here, this is just an example, but this repeats itself. The structures are very high always, is most of it, you know. Then you have vertical structures, facades, foundations, and so on. And then it also shows you where it goes. Most of it is always for materials, but then if something goes to transportation, replacement, waste, and so on. So you have to say where the address of the project, you always have to say that because it will calculate all these things automatically. And then it will tell you.
So can I make a question? Just do you are saying that you are calculating transportation, but are you meaning that you have all the locations of all the materials that will be used inside your objects, or this transportation is more for other sources, not for the building materials? My point is, usually if we want to make a really realistic calculation of the impact of a building, we need to know where the materials they come from, not only the reusage, but also where is the source of materials, because it's different if the factory is next to the construction or is in China.
Yeah, we buy a lot of materials from Latvia. So in the EPD, it says where the product comes from.
But is inside your BIM model also that information is? Are you? You
only say where the project is, where the site is, and then you connect the building objects to which material you're going to use. So yes, if you choose, for example, a window that comes from Latvia, you will understand that relationship between the product and your location.
Okay.
It's super advanced. I mean, I'm super impressed with this program. It's so smart. That's what I have been thinking. How are we going to do this just with parameters? I don't know, guys. I think this is going to be very cool to follow up. So you get of course, the total tons of CO2, the carbon footprint, and you can even ask if you put in a little bit of information about the country and some basic information that is available. You also get the social cost of offsetting the carbon footprint of the building within 60 years. And of course, you can see a bit more specific where the green gases are being located. And then, of course, how is it classified? This is, more for the maintenance and the use of the building. So are you going to use the heating that is already available, or are you going to have some sort of renewable sources within your building? So it will compare all those things. So we have been thinking, how are we going to make this happen for us? You know, what this means for us as architects. So we think that maybe something that can help on this reuse mentality is to start thinking a little bit more modular. So using parametric design and modular design could maybe be a way to go for us to actually embrace this mentality of flexibility, adaptability, and letting the project growing with the needs and being able to create this possibility to take on and off things. So this is something that is work in progress. I don't have much for you at the moment, but it's something we're looking into. And of course, designed for disassembly. So you have one module, if we arrive that that's a way to go. And from there, what kind of materials you could actually use later on. So if it's structural or if it's, prefabricated objects. So disassembly and prefabrication are very connected together. And, we're thinking, you remember that the mapping of the Lilia Caribbean project. So they went to the site and physically do inspections and try to understand the materials. But if we do that from the design perspective, maybe we can optimize how much of it can be reused. So I thought I would show you, this is a 4D model of one of our buildings. And we have been using this 4D technology since, 10, 13 years ago. So this is showing the progress. You see here in the left is all the new objects that are coming into the design and how they are going to be built together on the site. And we use this for construction purposes, for scheduling purposes. We have been doing this for a while. So I have been thinking that now we need to reverse the process, but it's the same technology. So we need to do this, and then we also need to do it backwards. What is going to happen when we finally need to disassemble this entire building? And so you see, it's just the same tech, but then you find new, more interesting uses for it. So this is also something that I'm looking into now. And I think that was the last slide. Whew.
Wow.
Geez, I talked for so long. Okay, guys, so tell me. Maybe I should stop sharing so you can... So we can see each other and talk a little bit. Oh.
Well, certainly a lot. A lot of stuff. I don't know. I don't know if anyone has comments or questions or topics you'd like to know more. I have some, but I will maybe leave that for later.
Please start, Ricardo, then we'll follow.
Okay. So one, well, I have one question that I didn't ask at when you were talking about finding out getting the list of materials from one specific project, is if you also classify how easy and is to disassemble. For example, if we have one carpet, or if we have just one wood floor, maybe we will lose, maybe when we are removing it, we will damage all of it or parts of it. How do you take that into account? You also test, or how you take that into account?
Yeah, that's one of the parameters on the mapping of the products, if it's even possible or not, because although they put a value on the existing concrete, you cannot reuse the concrete unless you keep the layout, right?
Yeah.
So the client was actually just having a presentation about it yesterday, how they are thinking that maybe part of it, instead of trying to recycle or reuse everything, is how can we make some dynamic new layouts using existing layouts. So I wanted to look into that as a combination. So it's not just reuse everything, but it's reuse the layout as one more factor into the equation. Because as you're saying, it's not worth it. You will demolish it, you will use more energy on demolishing it and reusing it than if you just throw it away. So,
but it's part of each product specification to say, can it be reused, right? I mean, that comes. I see that the carpet must be a different thing than a window. Mm-hmm. Whether it's easy to take away and replace and use it for the same purpose.
But that's why they had, I don't know if you remember, they had 4 categories. Top notch, the green one, like you can just reuse it very freely. Yep. Then you had the next one, you need to do something with it. And then the next one is recycle. And then the last one was garbage. So yeah, they took that into consideration. So they're also thinking that mostly all the cosmetic stuff, it's maybe not so very valuable. Yeah. I mean, nobody wants to reuse a carpet from 20 years ago. And the thing is
it's called a vintage factor.
But when you start looking at the impact of those materials, when we do the analysis on the Carbon Designer, you see that it's not much. So then it's really, there's no point. So we started putting together these pieces of knowledge, that need to translate into a methodology and need to translate into a service that we can offer and all this stuff. We are still in the early stages, I'm not going to lie to you.
Yeah, but that's and I don't know if that's a new beam use that we'll have to include in beam use lists in. Maybe it's already there. It's this assessment of existing materials. It's quite very interesting. Yeah, but this is one thing I would like to see in the future, if possible, is like how do you, maybe in greater detail, well, two things. Is one, how does that one-click LCA tool works in more detail, maybe, and then the other is that the laser scan into beam model automation. I've been seeing many papers about that, but it's always academic examples, and I've never seen it in action in a production environment to see if it's really worth it already. I'm sure that in the future it is, but maybe it's now. I'll really like to see more it on greater detail.
Yeah, we find this pretty good tool because we have been getting some models made by the same people that does the survey, but then they make a lot of decisions for us, and it was not really working. So as architects, we felt that it was important that we were part of that decision, and then we saw that we could probably do it faster, especially when we have a program that recognizes a lot of the beam within point clouds. So yeah, absolutely, we can give you a demo for that.
Good.
I would like to ask regarding the management of all the databases. I could understand that there is several information that comes from different sources. And I can imagine that to link the elements from the model to these sources, you can have to have kind of a code or something to link the elements to these databases. Do you use a common kind of classification code to link a certain object to different databases, or there is a specific code for each database that is connected with the model element?
Well, we have started using, for example, the manufacturers have started creating plugins. Our main drawing tool is called Revit. So, and I think it's either Revit or ArchiCAD at the moment. So they have started creating plugins that automatically connect the objects with their product information. So we just install it for that specific project, and then they themselves get access to our database through the plugin, and they do all the sorting, because that's not our job. I don't know what kind of window it is and how often you have to clean it. So they do that as part of their delivery. So this is it's a very good competitive advantage when the clients start asking for facility management information and they offer it automatically integrated in the model. That's like thumbs up.
Yeah,
so,
but I don't think here in Portugal construction works like that. Normally information comes from the offices, and I'm not used to, in my practice, for the construction companies or the construction, the companies that sell the materials to have this information at that level of development in BIM. So normally, if you want to specify or to be specific about certain thing, and you want to insert that information in your model, that's the issue I am. That drives us in this work with Ricardo. That it's how to manage information from different databases with a common view.
I have to tell you, so Excel is great. because when you go a little bit into the programming of behind the scenes in Revit, you don't need to be like a coding expert or anything to actually format Excel in a way that is compatible.
Yeah, I'm not saying that we need to invent codes. The codes, I think they already exist. There are classification systems. I think in my opinion, our strategy here in our work should go through as choosing kind of a classification system that is linked to several databases, maintenance, footprint, cradle to cradle, all this information. Maybe it's spread in different databases, but have a common, each element as a common code that links to all these databases. The issue here in our work is to choose this classification system that will enable us to create these databases that gravitate around the element. I think the issue is that I don't know which kind of, do you classify your objects according to a specific database? So when you deliver your models to the companies that will provide the objects for construction, they have the same code, so they can link the information they have in their database with your specific object that you've drawn on your model?
Well, there is not like a standard that everybody uses, so it's kind of project based. But once you understand what the client wants, then you just adjust your parameters to that. So for example, say that the life cycle of a window is 10 years. So what you can do is to connect those windows that expire in 10 years and allow them to tell you, okay, I go in cycles of 10. So after 10 years, you need to replace me, right? And they even have this like really stupid cartoon where you have a door and the door is like, who I am in the beam. And when do I need to be replaced? Like all this information that is relevant for every kind of object. But that's just something that you need to think about what are you going to use it for, and then we just adjust. So, I mean, look, what you're saying is totally smart. Like, we could have as a classification system that everybody can relate to. So, for example, maintenance routines, like cleaning routines, right? How often they should happen and how should they be executed?
Yeah, I imagine something like this. I'm going to give a stupid example. This is a door, and its code is A10. This code as a relation in a specific database that because of its characteristics says from like, for example, what you say about the 10 years of lifespan of the door is 10 years. This is a database that says, according to these characteristics, these doors, which code is E10, A10 is as 10 years of lifespan. This door in another database has these thermal characteristics. On another database with the same code, this door has this resistance or this air proof conditions. I don't know. The same code should, it would be simpler if the same code would be related to different databases that informs the model.
Mm-hmm. Yeah, and I think that's kind of very established all the way up to the construction phase, maybe as the as-built, but it's the last part of the circle, the building in use and the building in reuse. That's the part that it's still, like unknown territory. And I think for everybody. So what we have been trying to do is to sort of adjust to the requirements of the client and give them what they want. But yeah, it should be a standard, and it will be for sure at some point,
Yeah,
so, for example, if you actually build up a digital twin of your project, you could simply isolate everything in the building that needs to be replaced this year, and it will tell you. And it will connect you to the marketplace of things you can replace it with. So it's going to be like very dynamic. So when you think about a marketplace that will serve maybe different districts, different clients, then to use the same parameter is going to be crucial.
Yes, because then you can speak the same language on the life cycle of the project. When I say speak the same language is, imagine I design a building, I insert information in that model, and then the building is going to be constructed. If the construction company uses the same classification as I did, it can choose and it can relate with my model the same way I did when designing. So we can almost speak the same language with different BIM users in mind. And I think it's important to have a standard classification system that is transversal to all the needs during the life cycle of a building.
No, absolutely. That's why I think that this work you're doing is going to be so relevant, you know, because nobody is thinking standards. Everybody is thinking about how do I test it to work for my interest.
Yeah,
And
sorry to interrupt. In my experience, there's a saying here in Portugal, please, Luis and Inês, help me. You can hunt in different ways. You can hunt your objective in different ways. And here in Portugal, we are very prolific in managing ways to go around things and to achieve our goals. But the idea, we are very creative in that, but the idea is to make some resistance to that so that we can work on like a same language, a same code that could help us how do you say, go over this, our own way of doing things, because I have my own way of doing things at my architectural office. The consultants have their own way of doing things. The construction has their own way of doing things. Things get done, but they are not so efficient, in my view, and not so transparent. So this could lead in the end to the construction company remodeling a model just to work with it, because they cannot use the ones that we have designed because we didn't put the information in the correct place, not with the codes they use. When I say modeling is not modeling, I imagine that the company can do a really useful model, but the construction company, even though the model is well designed in terms of geometry, it's not with the information they will require.
But that's what I tried to show you. I have two things I want to tell you. First of all, this sort of a BIM specialist figure has gained traction in the last years because you need a person that can overwrite everything that was not done in the right way before. You cannot, it will get way too expensive if every time something is wrong, you have to send it back to the design team, they fix it, so that will be crazy. So that program that I show you that is called Simple BIM, that's exactly what it does. Once you have the IFC, it allows you to overwrite all the information that you want to change, and you can sort the information and connect it in different ways. And that's why I use the example. You have a wall that is sitting on the first floor, but actually in the drawing tool was connected with a round floor and an offset. So inside the program, I can override those properties and correct it. So it becomes, you become a bridge between the standards and the crappy job that sometimes you get. The other thing is that when you say those common standards, that is key. For example, all these things for construction are sort of established. I'm working in a project, very cool project in a small town in Norway called Gjøvik. They use the BIM model and say that the fire resistance is already standard, and it's an IFC parameter that we know where it is, and everybody uses the same, right? So we took that BIM model into a simulation program. So when the fire department is called to a site, they open the model, use the sensors, the movement sensors to see where is people, and they look around what kind of resistance the walls have. So they know exactly how much time before the fire goes inside. And then they can prioritize, even before they come to the building, who they are going to rescue first. So you see, having this sort of like common language has a lot of possibilities way beyond the BIM. So fire and sound and yeah, these things for construction, we have it pretty much under control, but it's a huge question mark with everything that has to do with what happens once we deliver the keys. You know, as architects, we just move on to the next project, and it's like abandoning a child at birth. How we are not actually leveraging more the knowledge that lays within understanding and following up on our own projects.
Like the empty nest.
Yes.
Can I just say one thing about this? I mean, we all know the need to make these standards horizontal, you know, and equal and one. But I think that we are actually at this point where we are now in Portugal, even though we are, you know, further behind in many aspects in regard to Norway, it might play to our advantage there, because as soon as you start creating a standard, most of the companies will do it from scratch, so they might as well use that standard. While in Norway, there's a lot of private companies that, as you say, trying to get, you know, the status of, you know, our products have already used BIM, blah, 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 and they each end up developing their own ways of doing things. So you come up to a point where there's like, you know, a lot of different things at the same time, because it wasn't
more difficult to make changes when many companies have already implemented their own.
Exactly. So I think it plays to our advantage that, you know, we are further behind on that process. So I'm not so concerned about you know, companies being resistant to change their methods. I mean, they will have to comply with the methods, and they will have to follow the standard, and that's going to make it easier to be just one.
Yeah, and most of them don't have a method yet. So if we give it to them, a method to do quantity takeoff, they will just gladly take it if it works. At least
also, like when it comes to, because that was one of the topics on the list that maybe I didn't go so deep into it, but managing the BIM, it's an art on itself, because as Marta was saying, maybe different companies deliver the same information, but it's in different places. Well, what about your own colleagues are delivering information that is in different places, you know? So suddenly I have like fire requirement with big letters, with small letters, one in Spanish, one in Norwegian, you know, the information is all over. So we have tools that we implement internally to also like coordinate that the information complies. And then, of course, when they give you these rule sets that you can automatically quality assure everything you do, it makes it easier. But we internally also have to manage this information in a smart way.
Mm-hmm.
Can I make a question?
Mm-hmm. Hi.
Thank you, Angie, for your presentation. It was very enlightening to us. I'm curious about public procurement, and if you can learn something with your experience. You said that you have just one public owner. That's not what we have here in Portugal. And you have some problems because lots of models, but they were not normalized. They were not can be certified and viewed in the same way, all of them. So what do you think it was about? It was because the requirements weren't very well established, or there were no certification of models, or anything else that we can learn with your experience?
Well, you know, like if we look a little bit closer into those requirements, they are very ambitious and very technical. So in that competition that I was working with Luis, I couldn't upload the file because there was something on the name. It was like a letter that was wrong. So for normal architects, or like, you know, people in the common people, it was really hard to spot those problems. And it was so many, it was so heavy. It's like an additional job on top of the design work we already had. So we were trying to comply, but it was a lot of extra work. And of course, the prize, the carrot in front of us was that the projects that they have are huge and very interesting and very exciting, but many people wouldn't even manage to compete. And so it was not a very democratic process. And, you know, like in Norway, they really want to build the best project possible and not to have the 5 same companies always delivering. So they understood that those requirements were a little bit too strict and that they needed to give something more for you as a user to be able to control this, that it was not exhausting or that it didn't require a specialized person within the company. Not all the architects have a person like me, you know. And so you have to make sure that in the moment they made it digital, and they made it like a rule set that you just run in the background and it will just tell you in red what's wrong. That already minimize, maybe I would say 85% of the struggle. Because instead of you creating your own routines for quality assurance, then they gave them to you. So they will measure again to see how much better it got. But those requirements were really, really hardcore, I would say. They are very high. So it's a little bit like that. Maybe now a few years later, we are also more used to it. And they just released last year the requirements for landscape architects. So you see, this is a continuous process. Nobody would think that landscape needs to deliver in this high level of BIM. But now when you start looking at the green, how they call it, green, blue strategy, what's water, what's vegetation, it becomes important again. So it's a little bit dynamic, but the reason why so many people didn't comply, it was because it was very, very technical. So you had to use a lot of text files as underlay of your models. And it's like, we are like drawing very freely, like there was no creativity involved in this process. So you cannot have architects doing that kind of technical work as part of their everyday life. I mean, I can tell you that I feel that in the future, the skill sets of an architect is going to be very different of what it is today. But right now we have all sorts of users, and just making it digital and automatical and accessible, it was a game changer for them. I think the next time they measure, they are going to get a much higher percentage of good models.
Thank you.
It certainly would. It certainly is a big advantage to have all public construction managed in just one institution, because then they really have the volume to have the best people around and to develop. It's not the case here in Portugal. Which is a pity.
You know, like regardless of the muscle of Statsbig, that I'm not questioning that they have a ridiculous budget, they are very smart in the sense that they sort of try to collaborate with other people. So when they were looking at how to digitalize those rule sets, they just chose a lot of people that was developing software and said, well, you guys work together with us, and then you will be the tool of choice for all the people that wants to work with us. So it's a way, you know, like they're quite smart in the way how they open the market. And by bringing people into the equation, you are willing to do a lot from your own resources to get into that position. So in my little humble position here in iLab, I try to do the same with all the technology companies that are trying to make it and find a place in the market. So I try to work with startups as early as possible, so they're actually willing to build something together with us.
That's very good. Well, more questions. People from Minho, do you have any questions now or comments? No.
But guys, just feel free to call me or contact me anytime afterwards. You know, it's I'm here for you. So just let me know if there's anything that was not clear. We can take a small session and look at things in a little bit more depth.
Okay. Yeah, we certainly will catch up later.
Yeah.
Okay. Now, so I will send. I have some. Well, at least we have just on the project, we have a draft version of the website. I will send the link. It's still not public, the link and the password for everyone to check out and give your opinion to improve it. It's just a first draft. So, but as we are getting to 4:30, which is a bit longer than we usually do, but it was totally worth it. But this for we'll just say goodbye, and we'll have a new meeting in 2 weeks. Okay.
All right. Very nice to meet you guys. Thank you for having me.
Angie, thank you very much.
Thank you, Angie.
It's
My
great.
pleasure.
Bye.
Bye.
Talk to you soon. Bye-bye.
Ciao.
Bye.